If you recall in the previous video, we were comparing taxes with cap-and-trade. Cap-and-trade is the quantity mechanism that sets a given quantity like Q star, yellow Q star, and says you cannot go beyond this. So this is an example of that situation. I'm going to talk about three firms: Toshiba, General Electric, and Apple. They are just cartoonish examples, okay? So let's suppose that each firm has some level of pollution, and also for each firm they have certain costs to reduce that pollution. Let's also suppose that there's a health organization that says that it's very dangerous to have 200 units of pollution, so you need to reduce to 120 units. So we're going to compare three alternatives to reduce those 80 units that we have. One would be to give each firm 40 permits. So divide the permits equally among the three firms. Another option would be to give those firms the same permits, but allow them to trade with each other. And the last option would be to give some auction of those permits and see what happens. So the first option is that we allow each firm to pollute 40 units only. They have permits and they are not able to trade with each other. If you recall, Toshiba had 70 units of pollution, so they need to reduce 30 units. And Toshiba has a cost of reducing each unit of $20. So reducing 30 units at $20 each would be a cost of $600. For General Electric, they had 50 units. No, they had 80 units of pollution, and they have to reduce 40 units, and each one of those units costs $25. So their total cost of reducing pollution for General Electric is $1,000. And then we have Apple, that it's represents a more efficient firm, and they have only 10 units that they need to reduce, and it costs them $10 to reduce each unit. So their total cost would be $100. The total cost from reducing those 200 units would be $1,700. Now let's look at option 2. We give each firm 40 tradable permits. So the same permits that we gave them before, just that this time they're able to trade with each other. Let's look at their willingness to pay. Given that for Toshiba it's costly, it's $20 the cost to reduce 1 unit of emissions, then Toshiba's willingness to pay for a permit, it's up to $20. Toshiba won't pay more than $20 because then it would be better to just reduce the emissions. For General Electric, the willingness to pay for a permit would be $25 or less, and for Apple would be $10 or less. On the other hand, if Toshiba has a permit, they would be willing to sell it if they receive more than $20. General Electric would be willing to sell their permits if they receive more than $25, and Apple would be willing to sell their permits if they get more than $10. So now I'm going to put these in a graph. In this graph, I also put certain the tables that we had before, so that you remember how much each firm is polluting, how costly it is for each to reduce their pollution, and I'm going to go through each price. If the price is less than $10, everybody wants to buy a permit. So Toshiba, General Electric, and Apple, everybody. And no one wants to sell. It's too cheap to sell. So there will not be any transaction at a price of less than $10. If the price of the permit is between $10 and $20, Toshiba and General Electric will be willing to buy a permit, and Apple will be willing to sell their 40 units, right? So there's something interesting going on there. If the price is between 20 and 25, General Electric will want to buy because it's still cheaper for them to pay anything below $25, but Toshiba and Apple would like to sell their permits. If the price goes beyond 25, everyone wants to sell, no one wants to buy. So you can see that there's an intersection of the curve at $20. So that's where the market will take us. The market will take us to a point where the transaction takes place at a $20 transaction. Toshiba will be indifferent because for them it's $20 the cost of reducing 1 unit of emission. So for them, they are indifferent between buying, selling, or cleaning up their own emissions. But General Electric wants to buy 40 permits and Apple wants to sell their 40 permits. So they will, make a transaction between them. Here I put a table with all the costs and income from these transactions. Toshiba, $0 from buying any permits, $0 from selling any permits, but they clean up their own 30 units, right? They have 40 units to pollute, 40 permits, but still they need to reduce 30 units, and each unit costs $20. So the cleanup cost for them is $600. For General Electric, they buy 40 permits from Apple at $20, and they pay $800, and they don't have any income from selling any permits, so their total costs are $800. Apple doesn't have any cost from buying permit. They have income from selling permit. That should be red. On the other hand, they clean up 50 units of emissions at $10 each. So at the end, they have a revenue of $300. So when I add up all the total costs, we have a cost of $600 by Toshiba, a cost of $800 by General Electric, and a revenue of $300 by Apple. This gives us a total of $1,100. So when the firms are able to trade with each other, then what happens is that the most efficient firm, which in this case is Apple, will do the cleaning, while the most inefficient firm, which is General Electric, will get the permits. And General Electric will be willing to pay to Apple to do this. What happens if, instead of just giving up the permits, we auction them? As you know, an auction works when someone is willing to give the highest possible amount of money for a given item. So the government steps out and says, who gives me $100 for a permit? Well, no one. Who will give me $25? No one. Until they reach a point of $20. At $20 or $20 with 1 cent, $20 with 0.1 cent, General Electric is willing to buy those permits. They will be willing to buy all 80 permits because it's cheaper to buy a permit at $21, $22, $23, $24 than paying $25 per unit of emission reduction. They will buy 80 permits. Their total cost will be $1,600. Then the government still has 40 more permits. Who wants to buy them at $19? No one. At 18, maybe, right? Actually, Toshiba would like to buy them at any amount less than $20, but they can wait until the price is at $10. To be true, it doesn't matter. The price, as long as the price is between 10 and 20, Toshiba will buy 40 permits. Let's suppose they pay $10 for each, so their total cost would be 40 times the $10 that they paid for their permits, plus 30 units that they reduced in emissions for, costing them $20 each. So their total cleaning up cost will be $1,000. Apple will clean all their 50 units at $500, and the total cost for the firms would be $3,100. The government will earn $2,000 from those permits that the government sold. Now, as you can see, the amount between firms and government can vary depending on when the bid, when the firm decided to break and say, I buy those permits at this price. However, for the total society as a whole, has $2,000 to invest in research and development, to give back to the firm, to reduce poverty. This is not money that it's being lost. This is money that it's within the economy. So the total cost for the economy is $1,100, which is the same as in the case of tradable permits. And this also tells us something very important. Once a government or an entity has decided to reduce emissions, reducing emissions is costly. Of course, it has to be costly. Nothing that entails these sorts of damages will be for free. If you need to reduce emissions, it will be costly. Now, the challenge would be to do it in the least costly possible way. And that will entail that the most efficient firms do the most cleaning up, and the most inefficient firms have permits to pollute. That way, we make sure that we find the least costly possible way to reduce emissions. And this is something attainable with tradable markets, and also under certain conditions with government auctions, as you saw in this example.